Hi, my name is Gary White, and today we're going to be overgoing parallel circuits. What are they, and how do they work? So the first part to parallel circuits is, what is it? Well, typically they come in many forms, but all parallel circuits are composed of two or more pathways from the battery. So which one of these circuits is a parallel circuit? The answers are B, D, and E. As you can observe, A, C, and F are incorrect because they only have one pathway coming from the battery. The next step to parallel circuits is, how does a parallel circuit work? Well, in terms of Ohm's law, where voltage is equal to current times the resistance, we need to think of this parallel circuit in terms of voltage, which is measured in volts, current, which is measured in amps, and resistance, which is measured in ohms. So how does one find the voltage of a parallel circuit? This is important. In a parallel circuit, voltage would be the same throughout the entire circuit. This means that if we were to put a voltmeter between resistor 1 and resistor 2, it would have the same amount of voltage if we were to put a voltmeter between resistor 2 and resistor 3. So how would one calculate the total current? Well, the total current is found by adding all the individual current of the individual resistors, so that IEQ is equal to the summation of the current drop of each resistor. It should also be noted that the total current is always going to be greater than each individual resistor. How do you find the resistance of a parallel circuit? For a parallel circuit, and only a parallel circuit, the total resistance is equivalent to the inverse of the sum of the inverse of the resistors. Now, you're most likely to see the first equation on your physics equation sheet, but you can also use the second equation to find the total resistance. It should also be noted that the Req is going to be less than each individual resistor in a parallel circuit. So let's do some example problems. Let's remember that the voltage will be the same throughout the entire circuit, and as we add resistance or branches to the circuit, the total current will increase while the total resistance will decrease. Okay, so for the first problem, we're looking at a problem where they want us to calculate the total amount of current found in the parallel circuit. So first, we're going to start out with a circuit composed of two resistors and a battery. The resistors are going to be in parallel, of course, and each going to measure 500 ohms each, while the battery will be a total of 10 volts. Secondly, we're going to use Ohm's law to isolate the variable we need. In this case, we're looking for current, so the variable we were going to isolate is going to be the I. Now remember that current is not the same across each resistor, so we have to do each resistor separately in order to find the total current. But also remember, voltage would be the same throughout the circuit, so the voltage would be the same across both resistor 1 and resistor 2. Now, going back to Ohm's law, let's go back and fill in the values that we know. So we know the voltage and we know the resistance of the first resistor. So we can fill in 10 volts is equal to I times the 500 ohms of resistor 1. Now if we switch it around, I is equivalent to V divided by the resistance, or R. So we have that I is equal to 10 volts divided by 500 ohms. If we put that in our calculator, we will find that the current is for resistor 1 is equal to 0.02 amps. Now, since the resistors are equivalent in value, we can assume that they will each have the same amount of current drop in the parallel circuit, so that the total current is equal to 0.02 amps of the first resistor and 0.02 amps of the second resistor. Now if we add those together, we can find that the total current in the parallel circuit is 0.04 amps. Now what we're going to do for the second part of this problem is calculate the total resistance, or the Req, for the parallel circuit. Now, in this case, to find the total resistance, we're going to use the first equation that was seen in the animation, also known as the equation seen on the AP Physics 1 formula sheet. We're going to put the value of each resistor under 1, or to the negative 1 integer, and add them together so that it equals 2 over 500 ohms. If we flip this fraction, we get 500 over 2, which is equal to the total resistance for this parallel circuit. If we simplify that, we can get that the total resistance is equal to 250 ohms.